Hey, my name is Dima, and in this video you will learn how to create and understand the more advanced player controller structure that you can implement in your Unity game. We're also gonna build a 3D prototype and create the thing that is called the StateMachine. Alright, so let's get started. So that is my empty project. The only thing I did here is I changed the X rotation of my camera and also upped it a little bit on the Y-axis. Another thing I created is the ground, which is basically just a plane mesh with a mesh collider on it. The first step I usually do is setting up my folder structure, so feel free to pause the video right here and follow along with the folder structure I have created here. Alright, so once you've done, we can continue. So the first thing we need to do is to create a replayer game object, so right click into the hierarchy, create empty and name it player. And also don't forget to reset the transform, and we can add our first component into it. So search for rigid body, because that's going to be a physics-based player. Select it and also freeze the rotation right here, and also change the collision detection from discrete to continuous and interpolate to interpolate. So the next thing we need to create is another game object, which is going to be the child of our player. So right click on the hierarchy, select player, create empty and call it visual, which is going to be responsible for visualizing our player or anything else that has to do with the player, like visual effects or anything else. And under visual, create another empty game object, which is going to be called player visual. And player visual is basically responsible for visualizing only our player and nothing else. And now we can create our player. So I'm going to go with a cube and give it a scale of 2. And also drag it up so you can see it on your camera. So the next game object we need is configuration. So create another empty game object and call it configuration. And configuration is going to be responsible for any config element that the player can get, like the jump height or move speed, for example. Another game object that we need is going to be called controls. And controls is basically responsible for any input or any other control element that we can add later on. So as said, we need the input game object here, so call it input. And the next game object that we need is going to be behavior. And behavior is going to be responsible for collision in our case, right? So another game object that we need is collision. So right click on behavior, create empty and name it collision. Alright, so far so good. Before we dive into the script, let's talk about the functionality of a state machine, and especially our state machine. A state machine is actually not a real machine. It is a concept in computer science that helps to organize the behavior of systems. It controls different states of a computer system, which contains different behaviors. So how does the state machine help us in our situation regarding the player controls and the movement? Let's imagine we have very simple controls and states. We have the idle state, the move state, and our input is only one button. So if we hold our button, our player is moving, and if we release the button, our player stops and does move. And in each state, the player has its own function. If we are in idle, we wait for input, and if we are in the move state, we process every input and calculate our velocity. In our case, it's just a little bit more than that. Our state machine is going to have super and substates. So let's say we start our game. Right from the start, we tell our player to start in the idle state because that's like the most default state we can start from. And our idle state inherits from a super state called state super ground. And both of them have different logic functions. In the idle state, we just wait for input and nothing more. In our state super ground, which is basically the parent of our idle state, we check if we are not grounded so we can switch to the air state, and if the jump key was pressed, we switch to the jump, and so on. So let's give our players an input. As we can see, we immediately switch to the move state, which also inherits from our state super ground. So in both cases we are grounded, and we can also perform our jump. And let's do it. So press the jump key, and as we can see, we switch immediately to the state sub jump, which inherits from our state super air. In our jump state, we check for negative velocity.y, which means that we are falling down. And right when it happens, we switch to the state sub in air. In there we check if we are not grounded and we have input, and if that is true, we switch to the move state. If there is no input but we are still grounded, we switch to the idle state. We also have the super state interaction, which is just responsible for interacting with, well, something, and that can only be triggered if we have interaction input and we are grounded. As you can see, it's not very complex, but there's still a few things to consider. So let's build our state machine. The first thing we need are scripts, and only scripts actually. So create those scripts in these folders, and once you've done this, open up the state manager. State manager is basically the base or parent class from which all other states inherit. So in here we need to get rid of the mono behavior because it's not going to sit in any game object, and define these two protected class variables. Protected state machine, and protected player general. We also need a constructor with exact 2 parameters, so let's create it. Then we need to reference them and say this.player equals player and state machine equals state machine. To define what's going to happen when we enter a state and also leave a state, we need two functions, which are enter and exit, and also make sure to define them as virtual. The next thing we do is creating a possibility to override all logical Unity-based functions, which are update, fixed update, and late update. And these functions need to be virtual because we just want to override them. Now open up your StateMachine script and also remove the mono behavior and all the Unity functions. Create a new class variable of StateManager and give it a public getter and a private setter. The state class variable is going to be our current state, because every state script is basically a child of our state manager, so we can basically specify which logic should be called at runtime. Now we need a function to initialize our state, and we also need to set our state in there and just enter it. The next function we define is our change state function, so let's say public void change state manager and state. And then here we say this.state.exit, just for exiting the state, and immediately after that we enter the new state, so init state. Now let's go into our player general script and prepare some logic in there. Remember when we said we don't want to put our state machine on any game object in our scene. Instead, we just want to create it from our scripts. So in here we say state machine, public, state machine, and referencing our state machine. So many state machines here. And also let's define a header for our components and put a rigid body on it. So header, components, and serialize field, rigid body, and rigid body. And let's do the same for the UI. And here we just want to display our current state on our screen. So header, UI, serialize field, text mesh pro, current state. In the wake function, we create our state machine with an empty constructor. And in the update as well as in the fixed update and late update, we say statemachine.state and now call the function from our state manager here that should run in this specific logical update. So in update, it's update, fixed update, it's fixed update, and late update, it is late update. To display the current state, we can use the update function for that. So current state.text equals statemachine.state.toString. Okay, so the preparation for our logic and functionality of our state machine is done. And now let's work on these states. Remember we said we want a parent state, which is in our case the state super ground, and then we have two substates, which is the state sub idle and the state sub movement. And now just create them as you see in the image right here and put them in those folders, and then we can continue. Alright, now let's start with the state super ground. Open it up and replace the mono behavior with state manager, because this script is a child of our state manager, so we can override functions and call the protected class variables and also create the constructor, in which you have to pass some variables into the base constructor, which in this case is our state manager constructor. Now we can just type in override, and as you see every function that can be overwritten. But for now, just leave it empty. Now open up the state sub idle and replace the mono behavior with state super ground. Remember, we can only be idle if we are grounded. And also create the constructor as you just did. Now let's open up the state sub movement and do the same here as you did in the state sub idle. Okay, so the problem right now is that we do not create our states anywhere. And that's what we're gonna do now. Create a new script in your state machine folder and name it state collection. Open it up and also remove the mono behavior here. So this is our collection of every substate, and in here we just want to create them. And the best way to do so is to create them in the constructor. So let's quickly do it. Create the class variables of idle and move state and give them a public getter and a private setter. Create the constructor by typing public state collection, and now remember all states do have a player general and a state machine in their constructor parameters. So that's what we need to do here. Add the player general and state machine in its constructor and say idle state equals state sub idle. And pass in the value variables, player general and state machine. And also do the same for the movement state. Alright, now let's quickly jump into our player general and create the class variable of state collection. Say state collection, states, public state collection, states, and reference our private states. And the awake function create a new state collection, say states equals new state collection, this state machine. The reason we're saying this is because we are currently the player general script, so we can pass ourselves to the state collection. And now let's start the state machine. In the state function, basically say statemachine.init, and now choose the state you would like to start from. Let's do the states.idle state. Go back to Unity and drag your player general script onto your controls game object. And also don't forget to set the rigid body here and create a new canvas for the UI text. So right click into the hierarchy, UI, text mesh pro, and place it anywhere you want. And also reference that text in your player general script. Alright, and now let's run the game and see what happens. As we can see, we are immediately in the idle state, so everything works fine. Now we need to work on the interesting part of that, the movement, and also being able to switch from state to state. For the input, we will install the new Unity input system because that way we can easily switch between keyboard and gamepad. And that's what we're gonna do now. So go to Window, Package Manager, and look for Input System. And there it is. So click on Install and we wait. Alright, so once it is installed, this message will pop up. And here you need to confirm that you want to enable your input system. So basically click on yes and your engine will restart in a second. So once you've done this, you need a new folder here. So right click on Scripts, Create, and select New Folder and name it Input. Open it up, right click in your input folder, create, and scroll down until you see Input Actions. Select it and call it Input System. And now open it up. Okay, so I will not go much into detail here. Instead, I can create a video about that, or you can just look up on YouTube for something interesting about that. But I will try to go slow here and we'll try to explain as much as I can. So the first thing we need are input schemes. So click here on this arrow right here, add control scheme and name it keyboard. Click on this plus icon and select keyboard. Set it to required and click on save. The next input scheme we need is the gamepad, as we said. So again, on add control and call it gamepad. And also click on the plus icon right here and select gamepad. Set it to required and click on save. And now make sure you select all control schemes, otherwise you will be working only for one control scheme and that's not what we want to. So all control schemes, and now we need to create the action map. So call it like general input. And now we need to get rid of this action here. So right click and delete. Now we need to create our first action. So click on the plus icon and call it movement. The action type of movement is value and the control type of that is vector2. Now right click the non-binding and select delete. Now click this plus icon here and say add up, down, left, right composite. That way we have our 2D vector, which you can easily map to up, down, left, and right. So click on the up, click on path. On the listen button right here, you cannot see because it's like a buggy version of the Unity input system, but it's actually fine. You can just click on this button right here and click W. All right, and now select keyboard and continue for the down, left, and right. I'm using the WASD scheme here. You can use whatever you want to, but this is like basically the way to add the controls to this action scheme here. All right, now we can work on the gamepad. So turn on your gamepad, and once you've done this, as you can see here, joystick enabled, we can click on this plus icon with the arrow down here and say add binding. And here just select gamepad, click on path, listen, and move your left stick. And I'll select the first one, because if you select the Xbox controller, you will only be able to use the Xbox controller here. So select gamepad. All right, and now click on save asset. All right, so go back to Unity and create these scripts in these specific folders as you see in the image right here. And once you've done this, we can continue. Now let's start with the most easiest script, the player configuration, which is gonna sit in our configuration game object of our player. Open it up and create a header. That's actually optional, but we're still gonna do it. So header config. So for now, we're just gonna create one variable here, the move speed. So type in serializable field to manipulate it from the inspector. Say float move speed, and now we need the public getter for this. So you can go for a public getter, but I'm still gonna do a public float move speed in uppercase and reference our private move speed. Okay, so that's basically like the scheme for any other config elements that you want to create in the future. You can go for move speed in air we're gonna use later on, or I don't know, like swim speed or something else. Just create a serializable field for that and create the public getter for this, referencing the private variable. Let's jump into our input processor script and get rid of the mono behavior here. Remember, we want to create it from the scripts and also get rid of those methods here. We don't need to create a constructor here because that's going to be an empty constructor, And if you know programming kind of a little bit, you know that the empty constructor is always there. You don't need to define it, but I mean, surely we can if you want to. So type in public input processor brackets, and here we go. That's the empty constructor. Now let's work on our inputs so we can process our inputs basically. The way we do it is actually pretty simple. Define a vector2 input vector and create a public vector2 input vector and reference our private input vector. You can also do it like the other way. You can also say like public vector2 input vector and public getter and a private setter. But I still kind of like this way to do it, so I'm going to delete this one. And now we need the normalized version of that to get the unit vector of that. That's basically the normalized thing here. So call public vector2 input vector normal referencing our input vector dot normalized. It's basically to avoid a longer distance when moving diagonally, because if you're not using the unit vector, you will be moving faster while pressing W and D, for example. So let's create our processor functions. So public void process input vector. In the brackets, you say vector2 value. And now we basically say this dot input vector equals value. If you're still confused here, well, don't worry. We will try to figure it out in a second, but just take this one here and put it in your script. All right, so save it and open up the player general. And here we need to define our input processor with a public getter and a private setter. So let's quickly do it. Go to here and say input processor. And now we need the public version of that. So input processor and call it input processor and reference our private input processor. Now go to the awake function and simply say input processor. There it is. Equals new input processor. All right, now we need to reference our player configuration, and that's going to be a serializable field. So go to here on the components and say serializable field. It's the wrong one, serializable field. And say player configuration and name it player configuration. All right, now we need to work on our movement script, which we have to create in here. So we can actually do it right now. So call player movement public, and now the public getter for the player movement. Let's simply call it movement and reference our private player movement. Scroll down to awake function, and in here we're gonna say player movement equals new player movement. And in here we need to pass in two variables, which we're gonna create in a second, but for now just keep it like that. And I'm going to explain what's going to happen here. So rigid body and player configuration. All right. And now we can open up our player movement script. So once we're in player movement, we can get rid of the mono behavior because we just simply said in the player general script, we want to create it from our scripts. So we have to get rid of mono behavior and also get rid of these two default Unity functions. And in here, we need to think about what kind of movement functions we want to create. So we want the default movement, which is basically like the function that moves our player and processes the data for that. And we also want a movement which basically like kind of stops our player. So we want the velocity idle and we want the velocity movement. And we can actually do this, but before doing that, we need to define our rigid body. And we also need to create the player configuration because we're simply passing our variables, the rigid body and the player configuration, to our player movement script. And we are setting them in the constructor. So we need to create those two variables here. And we also need to create the constructor here. So say public player movement and pass in the rigid body. Just name it rigid body. And the player configuration, just simply name it player configuration. And in that constructor, we basically say this rigid body, because we are referencing our rigid body from this script, equals rigid body from the constructor parameter list, and also say this dot player configuration equals player configuration. All right, so this is kind of looking good. And in the player general script, the error is now gone. So we can continue. And now let's define our default movement for the player, which is the velocity movement. So simply type public void velocity movement. And in the constructor, we're passing a vector2.inputVec. So in a second, I will also try to explain that, but that's basically like our input vector, which we create while using the keyboard or the gamepad. So let's say vector3 movement equals new vector3. And in the brackets, we say inputVec.x, because the x of our vector2 is referencing the x of the vector3. Zero float on the y-axis, because we do not want to move on the y-axis, like moving up or down. And we also want to move on the z-axis here. And for the z-axis, we're going to use the inputVec.y. And don't get confused here, because our inputVec.y sits on the z-axis for vector3. If you're pressing W or S, you're moving up or down, right? So you're going forward and you're going backwards. But the inputVec.y cannot be set on the y-axis of our vector3. If we're doing this, we're going to move up and down. So we want to move forward and backwards. So that's why we have to sit like the inputVec.y on our z-axis for vector3. I think that's kind of understandable. And multiply that with configuration. Let me see. Configuration, or the player configuration dot move speed. All right. We also need to apply this vector on our rigid body dot velocity. So rigid body dot velocity equals movement. All right, looking good. And now, as we just said, we want the idle movement, which is going to be the public void velocity idle. And then here we just say rigid body dot velocity equals vector3.0. So once we enter the idle state, we want to reset our velocity, because if we're not going to reset the velocity, our player is still going to move on the ground, and that's not what we want to. And now open up the input manager, which is responsible for the inputs that we actually do by pressing buttons or the gamepad axis, and create a serialized field, player general, player. So let's get rid of that and create a serializable field, player general, and call it player. All right. So we need to create the functions that actually pick up our input that we press basically. So let's start with the first one, the movement. And here we just say public void input movement and input action dot callback context. If you're still like kind of a little bit confused about that, I can create a separate video about that whole topic of input system and how to use the Unity events, etc. But for now, just keep it like that. You're gonna understand in a second what's gonna happen here. So in here, we need to say player.inputProcessor. That's the public input processor we just created in general script. And I'll call a function which is responsible for processing our input. So in our case, it's the process input vector. And then here we need to pass in our input variable. And in our case, it's the context.readValue. Remember, we defined our input as a vector2. So we say vector2 and open the bracket and close the bracket. Okay. The main base of that is basically done. So now we need to define how we want to switch in our states. So go to the state sub idle, open it up, and then here we can say override and enter, right? So we say player.movement, and movement is actually referencing our player movement script. And then here we just defined that we want to have a velocity idle. So select that and close the brackets. Okay, once we're on idle and we reset our velocity, we want to check if we have any input so we can switch to the move state. So let's quickly do it. Type in override, and now we just need to get the update function here. And now just say if our player.inputProcessor.inputVector.magnitude, because that's like the length of the vector, is bigger than 0, means we have input. And if we have input, we call StateMachine.change. And now what state we want to change to. So say player.states.moveState. Okay, so once our input is bigger than 0, so we have input, we switch immediately to the move state. And I'll open up the move state, and in here we just want to say override update, and we simply say kind of like the opposite of that what we just did. So we say player.inputProcessor.inputVector.magnitude is equal to 0. And if that's true, we want to switch to the idle state. So call StateMachine dot change player dot states dot idle state. All right. And to actually move our player, we need to apply the input to our player. And that's what we're going to do in this state step movement. So say override and select the fixed update. And then here we simply say player dot movement, and I'll select the velocity movement. And in the brackets, you have to put in the processed input. And the processed input is in our player dot input processor dot input vector normal. Remember, the normal one is like the unit vector, and that's where we want to use. All right, so the whole thing looks pretty good to me. We can test it out in Unity. So go back to Unity, and now we have to apply every script, or at least some scripts, to our game objects. Let's start with the configuration one. So select the configuration game object, click on add component, and we don't want to add rigid body. We want to add the configuration. So player configuration, and in here, select the move speed you want. I'm gonna go with, let's go with 10. The next one is controls, and in here we want to reference the configuration game object here. All right, looks good so far. Go down to input, and in here we just want to apply the input manager and also reference the controls. And here we also want the player input, so select it. Okay, so now let's apply the action that we just created. It's the input system here, and also make sure auto switch is on. And default scheme is any, that's correct, that's fine. Now let's switch to the invoke Unity events. So click it and open up the events. As you can see, our general input, this is our default map that we created in our action map. As you can see it also here. So open it up, and there we go. That's the function we just created. And in here we need to click on this plus icon here and drag in the input manager, because our input manager is going to be responsible for processing the data from the input system or from the input action, and to process it to the next scripts in our hierarchy, basically like that. And then here, select the input manager, which is this script right here, and see input movement. All right, looks good to me. So we can try to run the game and see what happens. All right, so let's start to apply some movement here. So I'm pressing the W key. We're in the movement state, pretty fine. I stop, we are in the idle state. Now I press the S key, we go back, I stop. Okay, so it looks pretty fine to me. I'm gonna try it with the gamepad now. So my gamepad is now connected, and if I move, it's looking pretty good. All right, so that's it for now. If you have any questions, feel free to use the comment section down below. And in the next episode, we're gonna work on how we can add more states to the whole system, like the collision detection or jump state, etc. So thanks for watching. I hope you learned something from that, and see you in the next episode.